We are from Group 1 and we'll be doing a presentation on petroleum processing and refineries. Our group consists of me, Aurelia Mranterisa, and Antaman Dunya Kausar. And lastly, we have Rifa, but I don't think he's here right now. So today's presentation will be mainly talking about the significant event in petroleum processing, process development driven by market demand, refinery capacities in the United States and in the world, basic operation categories, conversion strategy, refinery categories, and their configuration and their field products. Okay, next. Okay, so the history of petroleum refining comes from the successful drilling in Canada. Before that, oil was only available in small quantities, so its purpose was only on certain areas like medicine. And yeah, so because of the drilling, we were more accessible to petroleum, so it was able to be refined and used in various areas. So as you can see in the tables, these are some of the significant events in petroleum processing. Maybe next, Antama. So how does it get affected by the market demand? Demand of oil becomes more apparent when kerosene lamps were more popular. So refining always develops based on the consumer's needs. And as a result, petrochemical is now strongly correlated to economic activities. And the industry needs to keep up with demand, so they have to come up with the more efficient and cheaper ways to produce petroleum. Maybe Antama can continue.
Okay, so the next is refinery capacities in the United States and in the world. So according to the U.S. Energy Information Administration, the top 10 refineries in the U.S. have the capacities are listed in the table on the left side of this slide. Many of the largest refineries are no longer owned by large integrated oil companies. In fact, many large plants previously owned by big oil companies have been sold to smaller refining companies. The location of the refineries stays the same as refineries cannot be easily relocated. So we can see in the table, this is refining capacity by country. In MBPCD, thousand barrels per calendar. For example, United States in 2010, the number is 17,000, and 2014 it's almost the same, only a little difference. And the others you can see by yourself. And next is basic operation categories for refining processing. So there are separation process, conversion process, treating, finishing process, solvent refining, blending, and other operations. So first, the separation process. In that process, there is no change in size and basic structure of molecules. So there is only physical separations, no chemical reaction. And the conversion process. In this process, there is change in size and structure of the molecules. And in this process, there is chemical reaction. And in treating or finishing process, in this process involves the removal of undesirable components like desalting, hydrotreating to achieve hydrosulfurization, hydronitrogenation, and etc. So next process is solvent refining. In this process includes solvent extraction, dewaxing, deoiling, and usually to prepare lubricants and high quality waxes. And the next process is blending. In blending, uh, in this process is applied to both crude oils and the products. In this hydrocarbon fraction, additives and other components are mixed to produce finished products that meet product specifications. And the other operations, uh, we have conversion strategy. In this conversion strategy, for refiners, the goal of a conversion process is to reduce boiling point, primarily by transforming low-valued heavy fractions into high-value light products. This is accomplished by increasing hydrogen to carbon ratio through hydrogen addition or carbon rejection. The most common hydrogen addition processes are hydrotreating and hydrocracking, which increase the hydrogen to carbon ratio by adding hydrogen to the molecules. Taken together, these two processes are referred to as hydroprocessing. When discussing hydroprocessing, some authors include catalytic reformers, which generates hydrogen, and isomerization units, in which hydrogen is not consumed but is needed to reduce catalyst coking. The flow seems for fixed bed hydrotreating and hydrocracking units are similar. Hydrotreating is an essential precursor to fixed bed gas oil hydrocracking. Feeds and products for typical hydrotreaters and hydrocrackers are shown in table on the left. So in the table, it is feeds and products for hydroprocessing units. For example, the feed is heavy naphtha. So products from hydrotreating is catalytic reformer feed, and the product from hydrocracking is LPG, and the rest of it you can see by yourself. And next we have refinery categories. A refinery is an industrial complex that manufactures petroleum products such as gas oil from crude oil and other feedstocks. Many different types of refineries exist around the world. Refinery configuration evolves to meet market demands. Such demands are both economic and geographic. Some refineries in the U.S. Midwest mostly supply diesel for farm equipment. Almost all U.S. and European refineries are either conversion or integrated refineries, as are the newer refineries in Asia, the Middle East, South America, and other areas experiencing rapid growth in demand for light products. And we can see uh, the figure in the left side of this slide. Uh, this crude enters the distillation and produce different products. And next we have refinery categories. There is topping refinery, hydro skimming refinery, conversion refinery, and integrated refinery. And next There is refinery configuration. The process flow schemes for a representative high conversion refinery are shown in the figure. The configuration of high conversion refinery is very complex. The process for destination cuts other than residue, atmospheric and vacuum. Prior to being subjected to refinery operations, crude oils are stored in storage tanks within or adjacent to the refinery. Different grades of crude oils are usually blended to meet the refinery feed requirements or specifications and refinery constraints. And we can see the picture in this slide. This is integration of a refinery and petrochemical plant. And maybe Alia can continue this last slide.
Okay, so for refinery fuel products, in the figure illustrated how stream form individual process units might be blended into four major groups of finished fuel projects. As shown, the gasoline blender prepares finished gasoline from 12 different steams, and oxygenates or ethanol are added separate blender product called reformulated gasoline blender stock for oxygen blending, commonly known as reformulated gasoline. Kerosene and jet fuels are shown in the same box because their boiling ranges are similar, and the cut points of certain streams are changed based on the market demand, and some streams can go to 2 or 3 places depending on how it's cut. And straight run light gas oil can become jet fuel, kerosene, or diesel. I think, yeah. And you can see the chart on the left. That is all from group 1. If you have any question, please just ask.